This is my lab report for Lab 5, which I chose to do about collisions. For the introduction, the law of momentum of conservation states, for a collision occurring between object 1 and object 2 in an isolated system, the total momentum of the two objects before collision is equal to the total momentum of the two objects after collision. The law of conservation of momentum comes from Newton's second and third laws. Consider a collision between two objects, object A and object B. When the two objects collide, there is a force on A due to B, FAB. But because of Newton's third law, there is an equal force in the opposite direction on B due to A, FBA. From my experiment, I observed the collision between two cans, and it was an inelastic collision because kinetic energy was not conserved. Each of the cans had a mass of 0.381 kilograms, so mass 1 rolled towards mass 2 with constant velocity in the x-positive direction. Mass 2 was stationary until the collision. Both masses continued to roll in the x-plus direction after the collision. I analyzed the motion of the two cans colliding in Tracker. There were 3 observations taken: the initial velocity of can 1, the final velocity of can 2, and the final velocity of can 1. From the Tracker video, the velocities were obtained. For mass 1, we have VI1 equals 0.41 meters per second, and that was found using the time and position data from Tracker. Since mass 2 starts off at rest, the initial velocity for mass 2 is 0 meters per second, and the final velocity of mass 2 was observed to be 0.238 meters per second. Calculations using the law of conservation of momentum. So the momentum before is equal to the total momentum after. So MAVA plus MBVB equals MAVF of A plus MBVF of B. So using the data that we calculated in the previous slide and plugging this into this formula, we find the initial velocity of can 1 to be 0.0655 meters per second. Now we can compare the observed final velocity of can 1 with the calculated velocity. So the observed velocity comes out to be 0.119 meters per second using the position and time equation. And while both final velocities are very small, there's still a discrepancy which can be explained by various factors or errors that have not been taken into consideration. Some factors like these include air resistance, friction, not rolling on a linear path, human error using Tracker, the video frame rate, and the unevenness of the surface of the can and the floor.